Auzubillahi minash-shaytanir rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello students, my name is Oladimeji T.A., the physics teacher of S3PHYWK3P3 Model College, Ibadan. I'm welcoming you to the last period, which is period 3 for this week of our e-learning class. And remember, at the beginning of this week, we started the topic model of atoms. And so far so good, we were able to look at 4 different models of atom. We started with Thomson model. We also look at Rutherford's model, Neil-Bohr's model, and electron cloud model. Today, we want to look at the structure of atom. So we treat in details protons, neutrons, and isotopes. Let's begin. We all know that elements are made up of atoms. An atom itself consists of tiny nucleus, tiny but massive nucleus at the center. And outside the nucleus is a cloud of electrons which move around the nucleus. The nucleus consists of protons which carry positive charges and neutrons which carry no charge. The proton and the neutron together constitute what we call the nucleus. Practically, all the mass of an atom is concentrated at the center. That is, the nucleus is responsible for the most of the mass of the elements. So the protons, neutrons, and electrons are the fundamental subatomic particles of the atom. The electron is the lightest particle of an atom with a mass of 9.1 times 10 raised to the power minus 31 kilogram and a charge of 1.6 times 10 raised to the power minus 19 coulomb. The proton has a mass of 1.67 times 10 raised to the power minus 27 kilogram, and this is over 1,836 times heavier than the mass of an electron. You can see that the electron is very, very light. The charge on a proton is the same thing as the charge on an electron. That is 1.6 times 10 raised to the power minus 19 coulomb. The only difference is that the proton is positively charged while the electron is negatively charged, but they have the same magnitude of 1.6 times 10 raised to the power minus 19 coulomb. There are the same number of protons in the atoms of a given element, but different numbers of protons in the atoms of different elements. For example, there is only 1 proton in a hydrogen atom, but 11 protons in a sodium atom. Also, in a neutral atom, the number of protons equals the number of electrons. Since the protons and the neutrons are of the same charge, so if their numbers are equal, then the charges cancel each other out. Therefore, the element is electrically neutral. So the neutron has the same mass as the proton, but it carries no charge. So if we denote an element X by AZX, the letter A stands for the mass number, while the letter Z stands for the atomic number. The atomic number, which is also known as the proton number Z, is the number of protons in the nucleus of an atom, while the mass number or the nuclear number A is the total number of protons and neutrons in the nucleus of an atom. Thus, the number of neutrons in the atom of an element is the difference between the mass number and the atomic number, that is A minus Z. The carbon atom denoted by 12 C means that it has 6 protons, 6 neutrons, and a mass number of 12. The nitrogen atom denoted by 14(7N) has 7 protons and 7 neutrons and a mass number of 14. Since a neutral atom has the same number of electrons as the number of protons, therefore carbon 12(6) has 6 protons, 6 electrons, and 6 neutrons. An important question to ask is, if all atoms are composed of this same component, why do different atoms have different chemical properties? The answer lies in the number of arrangement of the electrons. The electrons comprise most of the atomic value and thus are the parts that intermingle when atoms combine to form molecules. Therefore, the number of electrons possessed by a given atom greatly affects its ability to interact with other atoms. The properties of the elements are periodic functions of their atomic numbers. So when arranged in order of increasing atomic numbers, the elements with similar chemical properties reoccur at definite intervals, that is, periodically. In regard to the electronic structure of electronic configuration, that is, the arrangement of electrons in shell around the nucleus. This suggests a periodicity in the number of electrons in the outer shell of the atoms of the element. The electrons in the outermost shell or shell of an atom are called valence electrons. These valence electrons are largely responsible for the chemical behavior of the atom of an element. If elements having the same number of valence electrons are grouped together, the elements falling within each group have similar chemical property. Thus, we note that atomic mass, atomic number, valence, and periodicity all indicate particularity of matter. Isotopes are atoms of the same element which have the same atomic number Z but different mass number A. Isotopes are thus atoms with the same number of protons but different numbers of neutrons. Isotopes have similar chemical properties, but they have the same number of electrons because they have the same number of electrons around the nucleus. Chemical combination is due to an exchange of outer or valence electrons between elements. In nature, elements are usually formed as a mixture of isotopes. For example, two naturally occurring isotopes of chlorine are chlorine 35 and chlorine 37. They have the same number of protons, 1717, same number of electrons, 1717, but they have different numbers of neutrons. Chlorine 35 has 18 neutrons, while chlorine 37 has 20 neutrons. For carbon isotope, the two isotopes of carbon are carbon 12 and carbon 13. In carbon 12, there are 6 protons, 6 electrons, and 6 neutrons. But in carbon 13, we have 6 protons, 6 electrons, but 7 neutrons. Also, for oxygen, there are 3 isotopes of oxygen. We have oxygen 16, oxygen 17, and oxygen 18. In oxygen 16, there are 8 protons, 8 electrons, and 8 neutrons. In oxygen 17, we have 8 protons, 8 electrons, and 9 neutrons. But in oxygen 18, we have 8 protons, 8 electrons, but 10 neutrons. Also for uranium, we have 2 isotopes of uranium, uranium-238 and uranium-235, both having the same atomic number 92. So which means that in uranium-238 we have 92 protons, 92 electrons, and 146 neutrons. In uranium-235 we have 92 protons, 92 electrons, and 143 neutrons. We also have uranium-234 of atomic number 92. So which means that we also have 92 protons, 92 electrons, and 142 neutrons. So before I will round everything up on this topic, let me give you a summary of all what we discussed on atomic structure, the protons, neutrons, and isotope. So far so good. We said that the electrons are moving around the nucleus at definite orbit, and the orbits are called shells and are assigned specific energy. The number of electrons in an atom is determined by the atomic number Z. The way the electrons are arranged themselves in an element is called electronic configuration. Electronic configuration determines the behavior of elements. So the first shell is filled first and takes a maximum of 2. The next shell takes a maximum of 8 electrons, and the third shell takes up to 18 electrons. So the maximum number of electrons each shell can contain is given by the formula 2n squared. The number of electrons in the outermost shell is important because it determines the chemical behavior of the element. So when the number of elements gained or lost by an atom to become an ion is called its valency. So the valency is the number of electrons in the outermost shell of an element. Electronic configuration, particularly the number of valency electrons, determines how the element reacts chemically. Elements with the same valency electrons are arranged into groups. So the reactivity of the element in each group increases as we move down the group. Along the rows, elements are arranged according to their atomic numbers. So the pattern obtained by arranging elements in rows and columns is given by the periodic table. The elements in group 1 are known as alkaline metals. Group 2s are known as alkaline earth metals. Group 7s are called the halogens, while group 8, which is also known as group 0s, are the noble gases. This is where we are calling it today. Until next week when I will come your way again, I want you to know that the questions on the topic will be uploaded on the school portal. So I would like you to go to the school portal, look through all the questions and answer them, and upload your solutions on the appropriate place on the school portal too. But make sure you do so on or before the deadline that will be stipulated on the assignment. Once again, my name is Oladimeji T, your physics teacher. I'm saying Assalamu alaikum wa rahmatullahi wa barakatuh.